I'll be speaking about BigQuery and how you can use that to do machine learning, data cleaning, and make predictions. And then we look at a small tutorial. Before diving into BigQuery, who am I? So hi, I'm Shreya. I'm currently working as a junior software engineer at BZI. I did a bachelor's in software engineering at Monash, which is where I developed my interest in machine learning through electives. That led me into doing a master in data science, and hence I'm here now. We can connect if you want. I'll pop up that QR again in the end. So what is BigQuery? BigQuery is a cloud-based tool from Google, which can be used to build machine learning solutions and also perform data analysis right where the data sits, there in the cloud. The data can be as big as petabytes, and it doesn't slow down the process because it's a serverless and auto-scalable platform. The user is not required to build or maintain an infrastructure, and it can be integrated with different tools and services. But the best part is that all of this can be done using a simple SQL syntax. So what are some machine learning challenges that BigQuery is solving, or how is it different than other data science platforms? The first is that it doesn't require an intense programming knowledge. So you do not need to know anything like Python or R to build machine learning models. All you need to know are some simple SQL syntax, and it gives an opportunity to anyone who's not from a programming background to build machine learning models. The second is data movement. So in traditional workflows, you have to move data between environments, which includes from the data warehouse to using something like Pandas to transform the data, and then something like TensorFlow to build the model. With BigQuery, the machine learning is brought right where the data sits in the data warehouse, eliminating these transfer processes. I'll be diving into the code now to see how BigQuery works. The data set I've chosen is based on Chicago taxi data. So this is the public data set that's available in BigQuery. And I'll just switch my screen now. So this is what the BigQuery console looks like. You have everything on the left here, your queries, your database, which has the model and the tables. Start with the first row. So here I'm just making a replica of the public data set. The naming follows as your project name, the database name, and the table you want to name, or the model name. Just to give you a rough idea of what the data looks like, you can see that here on the console itself, there's a schema for your table, all the details, such as how big the data is, and how much storage it consumes. And you can also review your data right here in BigQuery. You can see your data is pretty big, and it has a lot of null values and other data that we're going to clean up now. So while I was doing some analysis on this data, I figured out that there are some values we would like to eliminate to clean up the data a little bit. First one is something like speed. Some speeds are more than 500 km an hour, which seems unusual, or like 1,000 miles, or the miles are, we're going to restrict our miles between 0 and 300. Some fares also reach 7,000, which seemed a lot, so we're going to remove that as well. And the other thing I saw is some cost per mile seemed.
We make the font a bit bigger.
Oh,
that's
better?
That's better.
Okay.
Thank you.
Yeah, so also saw that some costs per miles were more than $10 or even more. Some research I did, as this data set is between the span of 2013 and 2023, and on research I found that per mile it would usually cost between $2 to $3, so I'm restricting it to $5 per mile to get a cleaner data. So that's how you can perform mathematics as well in BigQuery, and saved everything in a new table called clean taxi data. The next one is where I'm doing all the restrictions that I mentioned above. And you see, before that, also doing some outlier elimination. So this is during the using the quantile process where any data is considered an outlier if it's 1.5 IQ or above the third quartile or below the first one. That's what this query does, and this is what our final clean data looks like. So now it looks much cleaner. You'll see there are still some null values we haven't removed. This is because when you train a data model in when you train a machine learning model in BigQuery, some imputations are done automatically. You don't have to define them, and it's generic that a numerical value is imputed with the mean. One or multi-hot encoded is imputed with a new category, and timestamp is done with the mean. You can choose to do manual imputations as well if you like. Next I've done is split the data to training and testing. I've kept the testing data to be before 2021 and the training to be after. Before looking into the model training, I'll just introduce the model query. So looks like a simple SQL query where you create your model or replace if there's already one. The model name follows the same format, your project name, database name, and your model name. And then there are two clauses you can use. The first one is transform. Now this is an optional clause and is used for data preprocessing. Any mathematical preprocessing that you want to do, or if you want to concatenate two columns, you can even do manual imputation or standardization of the data in this clause. The second clause is the option clause, which is where you will be defining a lot of model parameters and something like how you want your data to split. So the input label column is the column you want to predict. Data split method is how do you want to split your data into evaluation and training. It can be auto or custom or random or anything else. And the split evaluation fraction is where you can tell how much of the data you want to use for evaluation. Added to these, there are more options you can use which are dependent per model you're training. So for something like the linear regression model, you can use an L1 or L2 linearization, and you can choose an optimal strategy. Max iteration can also be defined, and by default, early stop is already true, which means that it will stop training if it's already reached an optimal space where it's not getting better, even if it's before the 10th iteration. If you want, you can define it to be true if you want, or false. When you run this entire query, so the second part in the select is where I'm doing some more data cleaning. First is one-hot encoding for all our categorical variables, and standardization for miles and trips. So there are two types of standardization you can do in BigQuery, which is standard and robust. Robust one is more robust to outliers, hence I've chosen that. To see how the model looks like after it's been trained, it can easily be seen on the console. So it shows you all the information you gave it before, like split method, allowed iteration, and this is your training graphs. You can see the learn rate over iterations, and notice how it only ran 7 iterations when we gave it 10. That is because early stop was true. And here is an evaluation of our model, which looks pretty good for now. The other thing I wanted to show was how the data looked when we don't have a connection. And this would have shown you how the data was after we hot encoded or standardized it. So there will be more columns added as to one hot encoded value and key, as well as the data for miles and seconds would have been standardized to be around 1. around 0. The next thing we can do with BigQuery easily is hyperparameter tuning. All you have to do is add this one line which says how many trials you want to run in your hyperparameter tuning. Now 10 is not randomly chosen. The rule of thumb is the number of parameters you're trying to tune, it's multiplied by 10. So here we are tuning L1 regularization. So it's 1 into 10, and I've given it a range 0.01 to 0.1. You can also give values where you can just choose 3 or 4 values you want to use instead of a range and run that. This is how you can see your model after it's been tuned. So by default, hyperparameter tuning is done to get an F good value for R squared. And you can see it has chosen our optimal model to be the first one. You can have more data here in BigQuery, which shows you all the loss and evaluations throughout the iterations. And here's the final evaluation. For our model, it's come out to be pretty same in all runs. And there's the R values. It's chosen the optimal model for us already here. So these are the models that we just saw. To show some more examples for regression models in BigQuery, I've added a few more queries to show. So if you were to do a boosted tree regressor, these are some more options you can add to your query. And this is for random forest. The rest remains the same. Finally, to make predictions. To predict, all you do is define the model you want to make predictions on. Now this predictions will make a new column called predicted fair, and you can save it in a different table, I've named it predicted fairs. So just to conclude, what we saw with BigQuery and its advantages are that it's serverless, it's auto-scalable, and it is quick as it brings data into where you're building it. It's cost-effective as it's a pay-as-you-go model, and it decreases the complexity of coding as it's an extension to the simple SQL syntax that is easy to learn, has a low, shallow learning curve, and can be used by anyone who doesn't have a lot of programming background as well. Thank you.